So, what does this have to do with human beings? Well, this is a link now, and a missing piece in longevity. As people age, the amount of energy in their cells decline, mitochondrial dysfunction. So if we can have a technology that can reverse that, we can, at minimum, keep people younger longer. The next model that we went to was working with lobsters. And as it turned out, the technology that you're going to see today is based off of how lobsters completely defy the aging process. Now, I have another confession to make. When we first built this equipment in our lab, I have a lot of really talented engineers that I work with, and we were setting all of this up and going through all these trials, and we got the first drops of this new water coming out of the machine. I said, I've done it. I've created lobster water. And so I was telling Meredith about this, and I was talking to Wayne about this. And I said, guys, this is incredible. We have this new technology. I call it lobster water. It's going to revolutionize health. And Meredith said, question, is it too late to change the name? Needless to say, your product will not be called lobster water. But it is the key to bringing light into the body. And let's go to the video.
For those curious about the intersection of science, faith, and naturalism, there sure are some fascinating conversations and facts out there that speak to the concept of intelligent design, the debate on God's existence, the age of the earth, unfathomable mathematical coincidences, Bible codes, and more. For instance, with over 11 million followers on YouTube, Destin Sandlin from Smarter Every Day recently visited Vanderbilt University to do research with his camera rolling on the existence of something called the flagellar motor.
The implications for a biomechanical motor are insane.
Think this bacteria is somehow moving just to move? Think again.
This bacteria has an operating system.
Yeah.
It has sensors.
Yeah.
It has effectors. It has actuators.
Exactly. Yeah.
And it has feedback.
Yeah,
and
feedback.
I'm getting emotional.
I know,
because it's so it's a neat design, is what I'll say.
It is. It is.
And it is all made out of molecules and looks like a sophisticated biomechanical motor that only recently was brought into focus through intense magnification imaging and modeled by the School of Pharmacology at Vanderbilt. It's made up of molecules and is here by chance?
So the flagellar motor exists, and it's amazing. It's complex, and it reminds me of an electric motor, and I love it. Like, I love this thing, and I think it's incredible. There are implications for the fact that something so complex exists and is so integral to the creation of human life. I mean, this is fascinating stuff. So it also opens up a huge debate. People say, well, how can something this complex come to be out of nothing? The logic goes like this. If this motor system is composed of complex individual parts, and all these parts work together to perform the overall function of rotating, then how did the individual parts come to be? Did it all have to happen at the same time? What were the steps these components took to assemble into such a complex molecular machine in the first place?
Okay. So, let's talk about for a moment if we seriously want to take on this subject of human aging and we want to look at, is it biologically possible to stop aging and hopefully someday reverse it? is there any evidence that this could possibly exist? Well, what's so interesting is that when we go back to 2018, when we had the start of the release of X39, we knew that this was going to mobilize stem cells in the body, that this was going to support natural healing, it was going to turn on energy production, help to regulate inflammation in the body, support overall natural healing. We started to see testimonials where it looked like people were becoming younger. Here was one example. One person likes that. 5,000 people like that. So we started to see this evidence that as people began using X39, they showed physical signs of becoming younger. And in some cases, the results were dramatic. It certainly wasn't that case with everyone. I wish it was, but it wasn't that case with everyone. But we did have dramatic testimonials like this. So the question is, what's going on here? What can we learn, and can we come up with technology to apply this to everyone? Because it certainly looks like it's possible to at least reverse part of the aging process. And certainly copper peptide will do that. So let's take a look through the literature. And this is fascinating. I've used this example before, but it's worth emphasizing again. Oxytocin. Oxytocin is the hormone that we associate with love. It's the hormone that's released when a woman gives birth, so it allows for bonding between, I was going to say a woman. Is that okay to say these days? I think it's okay, right? Yeah. I'm going to say it anyway because I know there's men and women. And a woman is a woman. Okay? As a matter of fact, I think you should elect me to the Supreme Court because I can say what a woman is. Okay. All right. Anyway. So that's how it works. Now, here's the really interesting thing, though, about oxytocin, is that if we take old muscle tissue and we expose it to oxytocin, it will have a rejuvenation effect on that muscle tissue. So the muscle fibers begin to look like and resemble young, healthy tissue. So this can't happen unless we're having an effect on the genes. Now, we can understand this from the perspective of biochemistry. So when we're in a state of love, there's a state of reduced stress, anxiety, the body's calm, we're conserving antioxidants, there's less inflammation in the body. And ultimately, when we're not in a chronic state of inflammation, that means we're protecting our DNA. So it's kind of easy to understand on a biochemical process when we're thinking of prevention, but when we're thinking about age reversal, that's an entirely different subject. There's more going on here than simple biochemistry. So let's see if we can understand that. So let's take a look at lobsters. We're going to use lobsters as a biological model. And lobsters are able to defy aging. There have been lobsters that have been found that are over 130 years old. And lobsters don't age during that process. So if you were to examine the muscle of the lobster that's 130, it would look like it is young and healthy. There's no type of oxidative stress, no inflammatory stress, no signs of aging whatsoever. In fact, as lobsters get older, they get stronger. So we want to understand this. They're not going to die due to old age. Lobsters will be killed by a predator like human beings. They're going to get sick. or they're going to outgrow their shells. Those are the mechanisms in which a lobster is going to meet their end, but it doesn't happen through normal aging. So when scientists look at an explanation in the scientific literature, the prevailing theory is that this all has to do with the telomeres. Excuse me. So this is based on telomere biology, meaning that telomeres are the rods on the end of chromosomes, and they're going to control the number of cell divisions. So as we age, as human beings age, these telomere rods get shorter and shorter until finally we're in our 70s and our cells can no longer multiply and divide. In lobsters, that process never happens. Lobsters, their cells will continue to divide an infinite number of times. So of course, humans have these telomeres, and one of the searches today in telomere biology is to look for either a drug or a naturally occurring material that can keep the telomeres lengthened. So, all that information is true. However, what we found in our research is that this was not the whole story. It was part of the story, but it doesn't explain everything. So, what if there's more going on here? Let's see what we can learn. What if there is some natural living code that's responsible for the lobster's immortality? We already know that everything in the body is controlled by light. It's the way we were created, it's the way we were designed, and it's very easy to prove scientifically. The electromagnetic systems in the body, the electrical systems in the body control the biochemistry. So there must be a way to tap into this. How are the lobsters using their energy fields to prevent aging? That's what we want to know. So since we are in the business of treating the body with light, a valuable tool is spectrophotometry. Spectrophotometry is going to measure the energy that is absorbed or reflected or emitted by a material. And depending on the device, this will happen in the UV, visible, or the IR spectra. So we get our light source, it goes through a lens to help focus this, we get a spectra of light, and then we look to see when we're testing a material, how that material responds to these different wavelengths of light. So another question is, if we're going to look for the secret of longevity in a lobster, where are we going to look? So we have a research tool to do the examination, but where are we going to find this secret? Well, we can look to the Bible, because the Bible is going to contain incredible information. We go to the book of Genesis, and we go to the story of Noah. So there's evil upon the earth, and we could probably learn from this lesson today. There's evil upon the earth. God regrets creating human beings and wants to wipe everything out and start over, but he finds that Noah is righteous, and Noah is the one good man and his family on the planet. So Noah and his family are going to be saved. So we all know the story. So what's interesting here is how human lifespan changes in the Bible. As a matter of fact, there is a statistical analysis on this which shows that if you take the ages of people in the Bible as it's represented through these generations, that it forms a statistically significant decay curve. In other words, those ages were not in the Bible as a random number. They're an accurate representation of exactly what happened. And so what can we learn from this? Well, God says to Noah, okay, now you can go and eat the flesh of animals. So presumably, before the flood, people were vegans. We're eating fruits and vegetables. But now we're going to go ahead and eat the flesh of animals, but don't eat the blood, because the life is in the blood. So what if we were to take that literally? What if there was something in blood that hadn't been discovered? We all know what blood is meant to do, but maybe there's something else there that's been overlooked. So let's take a look. For lobster blood, there's a number of different varieties. And we turn to this scientist that's an expert, Robert Baer. And he's been studying lobsters his entire life. And we had a very interesting conversation with him. And one of the things that came out of this was that lobster hemolymph was being used as a treatment for COVID-19. And lobster blood is based on copper, of course. So what's hemocyanin? Hemocyanin is a copper-containing protein. So lobsters are the Vulcans on this planet. For all you Star Trek fans. Oh, so happy we got some Star Trek fans here today. Okay, a lot of Star Trek fans, all right. So, of course, we can't help but notice that in human beings, GHK is bound to copper, and that will reset about 1/3 of the human genome to a younger state. So I think it's fair to say, would a similar mechanism be going on in lobsters? Does the copper content have anything to do with the longevity? So we could look there, and what's the connection? So we pull up this research study that's done by Professor Joseph Kunkel. That's a big lobster. I'm not sure if it's just coming out of a broiler, though. I think it's alive, but I'm not sure. That would feed a lot of people. And here's what the spectrophotometry chart is going to look like on this. And I started to notice when I looked at this data that there were these peaks that were going on at 550 nanometers and 400 nanometers. So the visible spectra is between 400 and 700 nanometers. Anything under 400 is up in the UV range. Below 700 is in the infrared range. And you can see that there's these interesting effects that occur where these three different samples intersect between 700, 710 nanometers, and 525 nanometers. Okay, I know this is getting technically boring, but there's a reason why we want to go through this. So a moment ago, we were talking about musical scale and 432 hertz. So we did these experiments, and we showed that if we put music, essentially, into these electromagnetic coils, that we could accelerate the way that people healed. What does this have to do with wavelengths of light in lobster blood? Is there any possible connection? So the immediate thing that we notice is that if we start with a 432 based tuning and then we double the number, we're going up in octaves. So here's what I did. I took 432 and you continue to double it. And you can also put this into a online calculator for converting frequency over to wavelength. So there's a number of ways to make this calculation, but basically you can convert a musical note over to a wavelength of light. So that's what I did here. And we end up with 400, when you do the calculation, you end up with 432 hertz equal to approximately 631 nanometers. Now, I'll tell you why that's interesting. It's interesting because in the scientific literature, 630 nanometer light is one of the wavelengths of light that's used to turn on mitochondrial function. And 440 hertz is not. all musical instruments should be tuned to 432 hertz because it is harmonic with the human body. It actually promotes energy and healing. Alternatively, we can use 630 nanometer light to turn on mitochondrial function. But we're still going to, if we do that, we're still going to be stimulating the outside of the body. And the patches are still superior in this sense because we can turn on specific peptides in the body that you can't with normal light. But this is a very powerful piece of information. So let's take a look at this. So we go back to our lobster data, and now we have 550 nanometers is one wavelength of light that's coming off of lobster blood. 630 nanometers, we took that number based off of 432 hertz tuning because that's what we were using in our experiments. And my hypothesis was that 630 nanometer light is in the lobster, we just didn't detect it in the lobster blood. So I had that hypothesis. And then the other wavelength of light was somewhere on the chart, it would be somewhere between 700 and 709 nanometers, roughly. Those are the wavelengths we were working with. So this was my first invention that came off this process. I call it a biophotonic reflector and ended up getting several patents on this. And if you look inside this device, you'll see that we have a series of optical filters, very high precision optical filters, along with an optical grade mirror. So essentially, we take the light, the naturally occurring biophoton emissions from the human body, they pass through the filters, hit the mirror, and then come back to the human body, but only specific wavelengths of light stimulate the surface of the skin. So that was the idea behind this. Let's see if we could treat the surface of the skin with the same wavelengths of light that are responsible for keeping lobsters young. Did that make sense? Okay, that was the objective. We got 2 to 3 years of age reversal in 10 minutes. And the way we measured this was through looking at the cell capacitance, the size of the cells. So a measure of how cells age is in their size. As we age, the cells will begin to shrink. And the electrical charge of the cell will start to become smaller. It's one of the mechanisms that's not well known about how a healthy cell goes and becomes cancerous tissue and how ultimately cancer can be treated naturally. But that's a different subject. So we can correlate aging to the electrical charge around the cell. So when you use this device, the cells expand, cells become younger. But it's almost too rapid. So we wanted to look for other methods here. Now let's go back to this idea that we can use technology to create new forms of matter. Maybe we could take some of those experiments that we did and apply it to this new knowledge that we have. If we were going to create new matter, what would we do?